Hello everyone, welcome to the 8085 practical series, programming practical series. So in today's session we will study some programs. The first is addition of even data. So what the problem is given, calculate the sum of series of even numbers from the list of numbers. So we will be given some data bytes, a series of numbers will be there, and we need to add only the even numbers from the series. So the length of the list is in memory location 2200. So 2200 will hold the number, how many number of data bytes we have are there in the series. So if 2200 contains 8, that means there are 8 numbers in the series, and in that we have to add all the we must take all the even numbers and all add all those numbers. And the series itself begins from memory location 2201. So series begins from the very next memory location, and we have to assume that the number of the sum is of 8-bit number, so we can actually ignore the carries and store the sum at memory location 2300. This is what we have to do. Now how do we know whether the number is odd or even? So all the data bytes whose D0 bit is 1, they are odd, and if the D0 bit is 1, the numbers are even. So if this is the data byte we are having from D0 to D7, the 8-bit data, so this D0 decides whether the number is odd or even. If D0 is 0, the number is even, and if this bit is 1, the number is odd. Now how do we know this? So of course we will use the instruction rotate right. So when we rotate right, the contents of the register A, they are rotated in such a way that D0 goes into the carry. So carry will be set. If the carry is set, then the number is odd, and if the carry is not set, the number is even. So let us do this on the simulator. First I will show the program and then we'll start on the simulator. So this is the required code. We start at 8000. The first is LXIH2200H. We initialize the memory pointer, and these are the various other instructions, and finally we store this data. Now let us do this particular program, run this program on the simulator, so that we know what happens at each instruction. We will also store some data and see how this particular program works. So this is the simulator. We are into the simulator. This is the required code. Here we can see these are the various instructions here. I have done the instructions here, and then on the right side we have the data grid. On the data grid at 2200 I have stored 08. So 08 means in our data grid there are 8 numbers. Now the number starts from 2201. So this is I am storing 01 here, then 02, 01, 02. I am just entering these numbers. So when we run the code, it will only add this 02 with this 02 with this 02 and this 02. So in this 8 data bytes, 4 are even, 4 are odd. I have purposely entered this 1 2 1 2, so that I know what the result I am getting. So the final result is 2 plus 2 plus 2 plus 2 is 8, will get 8. Now let us run this stepwise. So with the first step, LXIH 2200, HL contains 22 and L contains 00. So HL contains 2200, and they also point to this memory location 2200. With the next step, we store the data from memory to register C. So this at this location 2200 we have 08. So this is the count. This is the number of data bytes we are having. So this count we are storing in register C. Next, MVI B00. So we are initializing register B to be 00. Although it was 00, but sometimes it may contain some data. So we ensure that B contains 00. Why are we using this register B? So as to save the partial result. Now next we increment the memory pointer INXH. So now the memory pointer is at 2201. So here we have the first number. Now what we do, we transfer the contents using this instruction move A comma M. So this instruction transfers the contents of memory to register A. So memory now contains 01. 01 gets transferred to register A. Now next step what we do is RAR. So RAR is rotate register A right through carry. So when we rotate this, what we get is carry is 1. So it means carry is 1. It means that the number is odd. Okay. So this is the only way which we can. This is the way by which we know the number is odd or even. So here we know that the number is odd. Okay. Now next instruction what we use JC. JC is jump if carry to 800F. So if the number is odd, it will jump to this 800F, it will decrement the count. But if the number is even, then it will go on adding the data. So because we are getting carry, you can see carry is generated, it will directly jump to the next instruction DCRC. So the counter decrements. So now there are 7 numbers left. So Next is J and Z. So if the count is not 0, it will jump to 8006. Go to the next number. So we go to INXH. With INXH, we come to 2202. With the next step, we move the content from memory to A. So now memory contains 02, and that 02 is in register A. Now we do the instruction RAR, rotate equivalent right through carry. Now carry is not generated, okay, because the number is even. 02 is even. So here we checks the carry, but carry is 0, so it won't jump. But what it will do, it will transfer the content from memory to again A. Now why are we, although A contains the data of the memory, still we are transferring that content from memory to A, because the content in the register A was rotated. As we can see here, 02 it becomes 81. So 81 is not the data, 81 is the rotated data. So we need to transfer the data from memory again to register A for addition purpose. Then we add the contents with B. So B contains 0, so A plus B equal to A, so it becomes 2. Now next what we do is we store the partial result which is in A to register B, because A will be used again to rotate the data. So therefore we are storing the partial result in B. So this will again, we do DCRC. Now C becomes 6, it is not 0, so it will jump to 8006. So this continues, okay, until all the data bytes are added. So all the even numbers will be added, and of course the expected result is of course 08 we will be getting at, okay. And as soon as the counter becomes 0, so this result 08, okay, it is in register A, and this STA, it stores the result of register A to 2300. So what is this, is the expected result what we are getting, it's 08. So 2 plus 2 plus 2 plus 2, or 4 times is 08. So that's how we do this program. So that's the whole result. So now let's go to the next program. Now the next is addition of odd data bytes. So here calculate the sum of series of odd numbers on the list of the numbers. The length of the list is in memory location 2200H, and series begins from 2201. Now here we have to assume the sum to be 16-bit and store the sum in memory locations 2300 and 2301. So there are two differences in the previous and this program. In this program we have to add the odd numbers, not the even, and the sum will be of 16-bit. So we may even get a carry, so we must keep a track of the carry, and the data and then the sum would be of 16-bit. So let us do this program. It will of course follows the same thing, just few steps are different. So this is the required code for the 16-bit odd number addition. So we start with LXI H2200, and these are the other instruction. Okay. We will execute this on the simulator, and then I will show you how actually the program works with each instruction execution. So this is the required code. Here we have the code LXI H2200, and the subsequent instructions are there. I will explain it when we are executing them. And on the data grid, we have to store some data. So at 2200 we have 08. It means there are 8 data bytes, in which some are odd, some are even, and the number starts on 2201. And here we have 10 7 7 7 7 5 4, then 6 8 7 7 7 7 8 0. So there are 4 odd data bytes, 7 7. There are 4 7 7. So we will be adding this 7 7 only. So because our program will be adding the odd data bytes. So if we add 7 7 4 times, let us see what we will get. Then we'll know what the answer we will be getting. We must know the answer. So let us do the calculation first on the scientific calculator. So I'll just multiply 7 7 with 4. So we would be getting 1 DC. So DC will be stored in memory location 2300, the lower 8 bits, and the higher 8 bit is 01. So 01 will be stored in 2301. So this is the answer we will be getting. So now let us execute step by step. With the first step, LXI H2200. So HL contains 2200, and this also becomes the memory pointer. So this is our memory pointer. HL is the memory pointer. Then with the next step, move C, M. The data from memory gets stored in register C, and memory is pointed by HL. So this contains 08, and this 08 gets stored in register C. So this 08 shows that there are 8 numbers. So this 8 is our count which we load in register C. So we need to run this loop 8 times. Then next is MVI D00. So we initialize register D with 00. Now this register D will be used to store the carry. So when we are adding, whatever times we are getting the carry, that number of carry will be stored in register D. So we are initializing D with 0 0, and we transfer this 0 0 to register B. So B also becomes 0 0. Now this B will be used to store the partial result. Then next step we do INXH. So we increment the memory pointer. So now memory pointer becomes 2301. So this 2301, we transfer the contents from memory to register A. So this 10, it gets transferred to register A. Now we will check this. So what our strategy will, we will take the number from memory into register A, and from register we will rotate that content, and we will know whether the rotate right to know whether it is odd or even. So after transferring the content from memory to register A, the next step is we rotate. RAR is rotate right through carry. Rotate accurate right through carry. So here we see carry is not generated. It means the number is even, and we need to skip this number. So here we give the instruction JNC, jump if no carry to 8014. So at 10801 we have DCRC. We skip this part. This part is for adding the data bytes. So we just skip this because carry is not generated, and it means the data is even. So we now decrement C. So the counter is decremented because we already took the first number, and then check whether the counter is 0 or not. So J and Z, it checks whether this counter is 0 or not. Now the counter is not 0 because Z flag is not set, and this is of course 7, not 0. So it jumps to 8007. At 8007 we increment the memory pointer. So now the memory pointer is at 2202. So we take the data from that memory pointer 2202 to register A. So now this is 77 gets stored in register A. Now when we rotate this, so 77 is an odd number, so as we can see carry is generated. So now we need to add this number. So now J and C, because this carry is generated, so J and C will not be executed, it will actually not jump. Okay, it will execute the very next instruction. So we again take the data from memory to A. Now why are we taking the data from memory to A? Because when we already took the data from memory to A, but that data was rotated, so it has changed. You can see this data is 3B. So now we again take the data from memory to A. We cannot directly add without restoring the data again. Then next is adding. So add B. So add B, A was A 77 and B is 00. So 00 plus 77 is 77, and it gets stored in register A. With the next step we also need to check the carry. So if carry is generated, then it will increment D, but if carry is not generated, it will skip this INR D. So J and C, so here we can see carry is not generated. So when carry is not generated, it will jump to 8013. So carry is not generated, so it won't increment INR. It won't do this incrementing of D. It will jump to B comma A. So now the partial result is stored in register B. Now why are we storing the partial result in register B? Because A will be used for rotating the data. Then again we decrement the count. If the count is not 0, it will jump to 8007. So at 80 we again increment the memory pointers. Now it is the 2203. Okay, 2203. We again take the data from the memory. Okay, and this step, all the things are repeated until C becomes 0 and all the data bytes are checked. And I'll just go stepwise. Okay, you can just see this, what are the data are going on. This steps will be repeated until C becomes 0. Okay, so when C becomes 0, it will come out of the loop. So 3, okay, then 2. You can slow down the video and see what the contents are changed. So as C becomes 0, we are done. Okay. So we are done. When C becomes now DCRC, now C becomes, you can say C becomes 0 with this step. So it comes out of the loop. Okay, now we are giving jump if no 0 to 8007, but 0 is generated. Okay, 0 flag is set, so it will come out. And here again move A comma, we are doing this again. Why are we doing? Because as you can see, A contains previous data, rotated data, which was actually an even data. So it will contain 40. So we need to restore the partial result from B to A. So that is our final result. So this becomes DC, as we were expecting the answer as that. And with STA 2300, the data from register A is stored to 2300. With the next step, D contains the carry part, and D contains 01, that is stored from D to A, and from A to this memory content. So we cannot store directly D to memory, so we have to transfer D to A and then STA. So this is our answer, 01 DC. That is what we got in our calculator. So next is, of course, so this is how we execute this particular program. So that's all for this session. Thanks for watching.